Hello, welcome back to CSC 263 Database Management Systems at Adelphi University. Today we'll continue our discussion about database internals. In the previous video we talked about indexes and B-trees, and today we'll talk about recovery and backups, an important topic when it comes to ensuring persistence of data. A database management system is just an information system, and as a result it must be managed typically by an IT department in the way that any of the other information systems that are operated by that IT department are managed. One important element of that is to create data backups. We want to make sure that we prepare for worst case scenarios, and that would be a backup. In case that there is a catastrophic failure of hardware, in case there is a significant loss of data due to an invalid operation that was executed, we want to go back to a known good copy of the data at some point. An IT department does that for all of the systems that they operate, and the database management system is no different system. It needs to be backed up appropriately as well. Now, backups are difficult for a number of reasons. First of all, a backup needs to be made to some form of persistent storage. And that means that if I have a database that is, say, 100 gigabytes worth of data, then my backup will be at least 100 gigabytes worth of data as well. And that means that if I'm running a backup, I need to have a way to store it. Now, I could just make a copy on the hard drive of my computer of the data. But if I'm planning for catastrophic failure, I should also be planning for the fact that the computer to which I am backing up my data might fail also. If I'm just doing a backup to be able to restore data after an oops operation, that's one thing. But backups typically are not meant for that. Typically they're really meant for, oh, the building is on fire, or we just had a massive flood, or a tree took out the data center when it fell over during a storm. Those are the kind of emergencies that we want to prepare for. And a backup is one option. So we could back up to disk, but then we have to make sure that we back up to a disk that is significantly far removed from where the original disk is, so that at least it's unlikely that both disks are taken out at the same time. Especially for large volume storage, disks are expensive, and so many organizations still rely on tapes for backup. For an person who isn't used to IT operations, tapes sound so much like the 1990s that it's almost unbelievable that we're still using them, but yes, we are. Tapes have a number of benefits. They're relatively inexpensive, they can hold a tremendous amount of data, they are relatively fast, and they stay for a while, but also have a small form factor, which means that you can easily transport them around. Now, of course, taking the backup is only half of the effort. The other half would be restoring it and making sure that it works when it's needed. But all of that are things that our IT department is good at. This is what they do for a living. Now, databases add an extra level of complexity there. Because we want to make sure that the data remains correct as it is being backed up. And that means that data integrity in the database must be reflected in the backup. And that can become a problem because it does take a while to make a backup. And it could mean that, the backup starts and the first half of my database is backed up. And as the second half of my database is being backed up, changes might already be being made to the first half, which means that the first and the second half of the backup are now out of synchronization. And that means that we have a database potentially in an inconsistent state. And that's not a good thing. We want to make sure that the database is correct as a whole, or not the changes don't take place. That transaction property. And so as we start making these backups, what we really should be doing is freezing the database at a point in time that the database does not update while we are taking our backup, but that would be an interruption of service, and that's undesirable in many cases. So the mechanism built into the database must exist that we can ask the database for the state of the database at a given time, at least long enough that we can make a backup of that data. Backups also take time, which means that if we want to take regular backups, we might not have finished our first backup while we are starting the second one. So there's a lot of complexity that comes into backups of data, and the database management system must have a mechanism in place that when we take a backup of the data, that we know that that data is in a consistent state. The other aspect to keep in mind is that backups for disaster recovery are one thing, but that the system as a whole should be resilient to, say, software interruptions or brief power failures as well. And that's especially important when you realize that a computer has two types of memory in general. You have the primary memory and we have the secondary memory. And the key difference is that the primary memory is fairly fast compared to the secondary one, but that when power fails, the primary memory's content are lost and the secondary memory contents are preserved. Which means from a database persistence perspective that I really wouldn't want to have any data in my primary memory. However, primary memory is so much faster than secondary memory is that just to get any decent level of performance out of my database, I must have my data in primary memory. So there's always that fight between primary and secondary memory where one is persistent across power failures, but the other one is fast enough to actually be usable. So the database management system must have a mechanism built into it to synchronize between primary and secondary memories. The operating system does that too, to an extent, but operating systems might delay writing stuff from memory to disk for optimization. In a database management system, we don't have the luxury, we can wait. So we have to find a mechanism in our DBMS to ensure that things that we write to primary memory are also recoverable even if they haven't been flushed to secondary memory yet. And so that's nearly impossible, which means that the DBMS must make sure that it knows what data is being flushed to disk. And that means that when we commit transactions, that at that point that primary memory is flushed to disk and that we do not continue and say yes, commit successful until we have received confirmation that that memory has actually been saved. And so dealing with just that low level of how the operating system works is tricky. Now, between flushing to disk and making backups, there is a gap there. A backup is just a snapshot in time. Typically, we make a backup once, maybe twice a day, not every 5 minutes. It just takes too long to complete a backup, but it does mean that we have a window of vulnerability. It means that if I make my backup, say at 2 o'clock every morning, that any data that is being saved to disk between 2 o'clock every morning and 2 o'clock the following morning is subject to loss if that disk fails. And we don't want that. We want to be able to ensure persistence of the database. And so what many database management systems do is maintain a journal of activity. And that basically means that the database management system knows when it's being backed up and that it keeps from each backup going towards the next one a record of all the transactions that are successfully committing to the database, so that if a database has to be restored from backup, we can replay that journal of transactions and recreate the database up to the point that that electrical failure occurred. Now, of course, the journal is typically much smaller than the database itself because it only contains the changes. But it also means that we should make sure that the journal does not sit on the same disk as the database, or maybe not even on the same server as the database, which brings with it a whole level of complexity. Because otherwise we would lose the journal with the database, and it's pointless still once more. The journaling aspect happens between checkpoints. So the checkpoint is the moment where we know we have a known good state that we can revert back to if we have to. The journal keeps track of every single operation between that point and the next checkpoint or the next backup. In addition, the journal and the database management system itself can also keep an audit trail, so that we can review the activities of the database, make sure that only authorized activity took place, but also to make sure that all activity completed correctly. Backups sound simple, but they are not. Taking a good backup and being able to restore it is extremely difficult, especially when the data that you're backing up is changing continuously. It also opens you up to the vulnerability window between backups. And that's where the journal comes into place, that allows you to first restore a backup and then replay the journal to get back to as close to data as you can get it. The database management system takes care of that as well.